Our focus at GTC is to discuss our latest software release. And one of the things that's very interesting about that is we've added the ability to do migration support. Essentially, it enables us to perform maintenance without impacting the end user. Virtual GPU technology allows us to take a physical Tesla GPU that's in a server in a data center or in the cloud, and to provide it virtually so it can be shared by multiple users. The first is for a general purpose virtual desktop user. And what we found is that as organizations move to Windows 10, Windows 10 is much more graphically intensive than Windows 7. And so having a GPU for the operating system, but also for applications such as Microsoft Office, for collaboration with Skype for business or for WebEx. So that's the business user, which is one key use case for virtual GPU. Another one that your readers may be familiar with is for virtual workstation users. For using 3D graphics, high-end graphics users, when you virtualize a GPU, you allow multiple users to share the GPU, and they think they only have one. They each have their own. And this allows them to have access to high-end 3D graphics from any location, as well as on things like tablets and smartphones. It helps in two major ways. So one is the fact that you have a GPU which has a graphics engine. So VDI or virtual workstations without a GPU, they're not certified to work with the applications, and they don't provide the capability to deliver the rich graphics that a user needs. So the first part is just providing more raw power into the remote desktop. The second one is that when the system creates a virtual desktop, the GPU will be asked to render it, and then typically the CPU will take that rendered image out of the GPU and transmit it remotely. With our GPUs, we can do those last two steps inside the GPU. So we will capture the desktop and then we will encode it. And what that does is it provides greater performance, and it also enables you to put more users on a server. There's a couple different ways that costs can be saved. First, one is through capital expense. So it's much more cost effective to run, let's say, 15 users in a data center where they're sharing a GPU on one server versus buying 15 workstations, one for each user. So from a capital expense perspective, it's cheaper to provide a virtual workstation. And then the other one is the operational expense, that if you have to make an update to an application, you can update it once in the data center with a virtual workstation versus going to every user's desktop to update it. So it's cheaper to purchase and set up, and it's cheaper to maintain. So with the virtual workstation technology, it's proven to be very popular and cost effective in industries like manufacturing, architecture, engineering, and construction, media and entertainment, financial services, and of course, government and educational use cases. Whenever there's a real need for high-end 3D graphics, we've been very successful.